Hi everyone, this is a thought experiment on one-way speed of light. So it all started when I watched this video from Veritasium, why the speed of light can't be measured. And I'll just put in the link. It goes into great detail, 19 minutes of it, explaining why we haven't managed to measure it. So I thought, let me come up with a thought experiment. Maybe we can measure or try to measure one-way speed of light. So let's set up our experiment. Imagine we are in a vacuum and we have a light source. I just put in torch, excuse my PowerPoint animations at this point. We have a timer A, a light sensor, and timer B, 1000 kilometers apart in a vacuum. Right, so to start our experiment, we are shining light from our light resource, and then our light sensor is receiving it. Cool. Two more things, and then we will start our experiment. So we have two timers, they're all set to 0, and start button basically. This is very simplified for us mortals. The whole idea is that when I click the start button, imagine we have atomically in an instant managed to turn off the light source and start the timer A. Right? So that's the left side of the experiment. And on the right side, we have this timer B and the light sensor. So what we're telling timer B is to just stay at 0, right? Do not start counting. So what the timers are going to do, they're just going to start counting at the signal after given to them. And they're going to count in nanoseconds because that's the smallest we can measure. So what we're going to tell timer B is to wait, right? Be happy as 0 as long as you receive a light into your light sensor. The second you lose the light from the light sensor, start counting. So that's the timer B logic. The second you lose the light from the light sensor, start counting. And the left timer is the second you shut down the light to the light resource, start counting, right? So this is a whole mind boggle basically. But how do you measure the fastest thing in the universe when your only capability of measuring is using electricity, which uses that fastest thing in the universe itself? And the whole time dilation and the Einstein, relativity theory, you can't do this with clocks and synchronize the clocks to measure this. So let's start our experiment very naively, right? And then when I click the start button, timer is increased and we shut off the light source in the same instant. That's our assumption. As the time progresses, that light beam basically now it's the light resource stopped emitting light. And the light beam that was here, of course, has a direction to travel. It's here now. It's traveling, right? And we go to the next instance. The timer has increased on the left-hand side, but the light is still traveling. It's impossible for us to grasp the concept and the speed of the light. That's why I'm very simplifying it with the arrows and the light resource. So as the time progresses, the only light beam that's left within the reach of this timer B that hasn't traveled through this distance is this last guy. And then, as you can see, our timer on the left kept increasing, and our timer B on the right is still because the light is still reaching the sensor, right? And the next instance, when the last light reaches the sensor, there we go. Our sensor doesn't detect any light coming anymore, so starts the timer. So this is where we can theoretically finish the experiment, and the massive benefit from all the time synchronization impossibility is that, well, we don't have to, go to this timer B at this time, or send a message back from timer B to timer A to say, well, this was my time, and then which travels at the speed of light. We're back to the same travels again. We can observe timer B whenever we want. It can continue to count till eternity, or whenever the timer B internal counter representation gets filled up, basically. And the timer A is the same, because as we know, speed is distance over time. Our time will be timer A minus timer B, and we know our distance, so we can calculate the speed theoretically, right? So you, given that you will have to do all the conversion to kilometers to meters, nanoseconds to seconds, etc. But we have to make mind-boggling assumptions here, because this is the brain melting stuff. We can't really comprehend the speed of light as mortals. It's impossible for us. Like infinity, we think we understand infinity, but actually we don't. We cannot comprehend it. Our brains are not wired to that way. And we have to assume, or somehow calculate and deduce, the time it takes for us to click this button or switch in physical life to basically send a signal to say, or cut off the signal from the light source to say stop emitting, and the counter to start counting, right? That our timer counter, same thing in my books. I apologize if I confused you. So we have to find a way to measure how long those two events take, because realistically and physically we cannot execute the same at the same time. We think we might, because it's very fast. Again, we cannot comprehend it, but it's impossible, right? To have this same things happening on a logic at the same time. One of them will have to execute before the other one, unless we go into quantum computing. I'm not sure about that. So I can barely function with this normal physics, right? Let alone quantum physics. So, and then on the other side, we have to account for also the delay from the light sensor to say, oh, yeah, I've stopped detecting light, and now you can start counting on our timer B. The whole comical side of this thing is that the fastest thing we have for communication is the electricity, and which also travels in the speed of light. So that's where all the brain melting stuff comes from. This, it might be the same test, the instant that when this thing sends signal to timer B is the same instant that the light can travel from that distance to this distance, right? We are hoping that this distance is vast enough for us to physically achieve and make a difference between this and this distance. But for the speed of light, so this is like a joke, right? This is nothing. 300,000 kilometers per second, or million. I can't even grasp the concept. So yeah, it's as I said, it's very oversimplification. Thinking, well, we might be able to achieve this, given that we make some assumptions to say this takes X amount of time, and this bit takes Y amount of time, and then once we can measure the difference between these two, as I said, it's gonna be timer A minus timer B, then we can make a rough estimate. I wouldn't say calculation, a rough estimate towards the speed of light. And this again, the idea came. We know the speed of light is, as you watch the video, is round trip divided by 2 is speed of light. That's the easy option, I think. And the reason why we haven't measured the speed of light in one way is the whole brain melting stuff and concepts, basically. Maybe quantum computing might have an answer for this, but that's all. I'll share the link and the resources on the video description. I hope you guys have a good time and thinking about this brain metal stuff yourself. Have a good day. Bye.